Good morning, good afternoon, welcome back. Can everyone give me a thumbs up if you can hear me loud and clear? Excellent, excellent. We hope you all enjoyed the keynote as well as the break. We are excited to have you back here joining us at the Highline stage. It is my privilege and pleasure to introduce to you Francesc Matu. Francesc comes to us from the healthcare segment on our industry solutions as one of our principal members. So Francesc is kindly going to be volunteering his time to take us through the healthcare interoperability and modernization initiatives. We do ask that you hold any questions where Francesc will be able to address them towards the end. And other than that, we look forward to walking through this demonstration with you. So thank you very much, and here's Francesc.
Thank you. So, just before starting, who of you think that one of the biggest challenges in the healthcare industry is about sharing data? So please raise your hands, okay? So, I'm Francesc Matu, principal at the industry solutions team, and I'm supporting healthcare and life sciences. So when we talk about sharing data, that is across different dimensions, across your internal applications so that they can communicate each other, across new applications that you deliver, for instance, to build telemedicine application, to build your liquid hospital system, to provide the healthcare data continuum that is between primary and secondary care, but also mental care. Also to provide a real patient-centric data exchange solution involving third parties like the payer or institutions, public institutions, but also the patient himself. And finally, also exchanging information with research labs, pharmaceutical companies. All of them have to drink from the same water, data. So in a hospital in the US, as an average, it's known that they have 80 applications. And this is one single hospital. Imagine in a group of hospitals where normally they have acquired different maintaining legacy systems. This diversity of application is really a mess, or it might be. And to provide the real patient-centric healthcare system, we should ideally envision how the finance sector is working for some of the most common workloads. For instance, here we are showcasing an online paying transaction where several partners, like the bank of the consumer, the bank of the retailer, but also the fraud systems, the card issuer, all interact seamlessly in a very short time, almost in real time. We would like to have that also in the healthcare industry, so that we get a new test, for instance, and immediately the provider has all the information, also the payer. And that's not always easy because it's really an unconnected environment. But at the same time, our data in the healthcare sector is much more complex than in the financial sector. And it's about unstructured data, laboratory tests, medical devices, medical images, and also even genomics data. And it's not only about the complexity about this data, it's the meaning of this data. The meaning of this data might be different from where it has been collected, depending on the hospital that this data has been collected and the systems that they are using. This data might be interpreted slightly different. And therefore, to achieve that, we heard about the interoperability, healthcare interoperability, a single word that requires a tremendous effort. And many companies started already this journey of the interoperability, often because there is a push from the government and they want just to avoid penalties. But within the time, many organizations start to think that it has inherent benefits because it will provide better outcomes, reducing errors, the fact of having all the information from the patient, and at the same time it might be key to have a differentiator, a competitive differentiator for our organization. But in parallel, we have to say that interoperability is not the only thing that we have to do to modernize our systems. We need a broader modernization today to be more competitive. That is having the data as a product. We need to unlock the data from existing solutions to bring them on a different focus to build a real data-driven organization. That is, we need to figure out, and this is unique per each organization, which are our data that we have to work with, which is the data that really provides the differentiation of our company. And once we segment this data in those domains, then we will build interfaces to consume this data. So all the applications across the organization need to access the same data through those interfaces, web services normally. And this is the way to really unlock the data, being us the owners of the data rather than the providers of the applications. So, and these journeys, the interoperability journey and the modernization journey, are succeeding in parallel, and both are sides of the same coin. Both of them require a big investment, and we need to think how to work with that. Organizations, therefore, start to think, can we leverage interoperability standards for modernize our applications? Because interoperability standards are based on the domain-driven design. They have a clinical model that everything is designed. So what's a patient, what's a professional, what's a disease, what's a medication? So we shouldn't reinvent the wheel. It's already defined. So can we reuse that? But the problem is that interoperability standards are not defined to persist data, but to exchange data. And the most common standard and used worldwide, and especially in the US, which is FHIR, which stands for healthcare interoperability resources like the URL on the web, because every resource has self-contained data with links to external data. And these resources handled the 80% of the exchangeable and standard data. This is the rule that they got when they defined this. They didn't want to achieve a clinical model for 100% of the data model. So they prefer to just get what's the most common data that EHR system use, and they limited this to the standard clinical data set. And for the rest, for this 20%, they invented the famous FHIR extensions, where I can agree with another organization and we define what's not in the standard, we just put it here and we will understand each other. But this is not the full need, the full requirements that applications require, because there are some other data that applications that you use internally that probably don't require anything to exchange with third parties. For instance, I'm thinking about the settings of an application or very specific information that I use in my application. At the same time, FHIR is not yet mature. From the 158 resources that today they have published, only 15 of them are in the highest level, which is the 5th level, which stands for the maturity of the maths maturity. That means that there are constant changes. Some of the changes are just adding a new value, a new field, or changing a name, but some of these changes even change the meaning, how we interpret this information, and that implies modifying everything in our database. It's a lot of work. FHIR, it might be useful for those applications that consume a limited data set. I would say, for instance, for building a master patient index, where we will need 1, 2, 3, 5 resources, then it's very useful. Also to build a catalog of professional and services, wearable applications. So it might be useful to persist and to build from scratch many applications, but always limited in the purpose and in the use of data. When we go to broader usage of the data, like a full EHR or even a patient summary, we will find many problems there. And it is because FHIR is not designed to persist data, as I said before, and the requirements for an EHR and for these applications go much beyond the possibilities of FHIR. I am from Barcelona in Catalonia, Spain, and we deal there with a very particular situation. We have about 60 hospitals, and they have 29 different IT systems, EHRs. Okay, that's a lot. That converts Catalonia in a long time experienced actor in the interoperability. And they have, every hospital maintains a team of developers, basically developing new interfaces to have interoperability to the national health system, which is every year constantly requiring more and more information from the hospitals. And they have seen that this is a tremendous cost, and it's an increasing cost. It will never end. So institutions will always request more information. Also happened here in the US. The 21st Century Cures Act, it already had the due date. But we already have new norms that we need to accomplish. So this will never end. It's a never-ending cost. So what they thought is that rather than thinking the applications about interoperability, why not building a repository that is intrinsically or implicitly interoperable? And this is what they want to achieve with OpenEHR. I don't know how many of you know about OpenEHR, but it's an initiative that, as a difference from FHIR, it is designed from a maximal data set perspective. So they have a huge data model, clinical data model, and then clients or organizations build their applications restraining the data set that they require for each use of the repository. Problem with OpenEHR is that you require a very large investment because you need to refactor the clinical repository, but also every application. And at the same time, it requires a deep consensus across a territory. So what's happening in Catalonia probably will not happen in other regions of Spain, and less likely to happen in other countries in Europe, probably. Italy, France is very difficult. There are some areas, the North European countries, some in UK, East European countries, that they are adopting it, but many other countries will not, and less likely, I think, in my opinion, to succeed in the US, because there is not a dominant payer for the providers. There is not the state paying the invoices, and at the same time we rely with a very limited number of vendors. So we maintain the same problem, and I didn't bring into this scene OpenEHR to say that OpenEHR is better than FHIR. I don't want to enter in these comparisons because they are different, they are complementary. Huh? But I wanted to bring OpenEHR just to say that there is a big pain in the industry, and that we need a way to solve this problem because interoperability becomes very expensive. Imagine that we continue with the journey of the interoperability, and we want to model a FHIR server in our organization. We would, the left side, we have a resource, in this case from a condition, from a patient, and relational databases. How do they model those objects in JSON that are normally used in JSON in all the applications? How do they store them in the relational databases? One of two, normally. Or they denormalize the data model, the resource in several tables, and then they build the joins between them. Or another approach, which is very often used, is that they get a blob, so it's like a binary object, and they embed it as one column of our table. As searching the resource, making it findable, is not easy once it's a blob object, then they need to add other tables storing data to easy find and discover the resource for the different fields, so they need to duplicate the data. And if they want to allow even deeper queries, I mean more complex queries, that I want to find all the patients that have similar name to these or these, they need to add another piece that it's a full text search engine, let's say Elasticsearch or OpenSearch. So we have arrived here that instead of simplifying the system that we have added new complexity. We have added a new actor that is the interoperability gateway, which is not a bargain. It's very expensive investment because you can even up to multiply by 4 the information that you have in your original system to make data findable, to have just the resources prepared to serve, to have the full text search engine, and also fill the analytics that you will want to have this data anonymized for future usage of your data. So metaphorically speaking, now the average of systems is 81 rather than 80. So the situation, it's really complex. So arrived to this point, how we would solve this on the world of MongoDB. So we have on the left side, in this case, the patient resource from FHIR, and in the right side, what we propose is to have, it could be a different way, but a possible way is to have just the resource, just like the definition defines in the standard. So everyone will understand what's in the database. But at the same time, you are not limited to interoperability. You can add all the metadata you require to run your applications. For instance, adding this metadata field. So the resource would maintain the object ready for a change. But then in the metadata, you could have particular information that every of your applications require. For instance, here you can see the Care Compass applications that has several fields that it will be used particularly only in that application. And this data is not part of the interoperability. So that's a proposal of how it could be modeled, but the idea, the conceptual model is that you can wrap on top of the interoperable resource the data you require. Also, if you want to increase the performance of your queries, and if you are worried of the hierarchical model for some query, you can bring out some of the fields and have them as search parameters. That's also a possibility. So we can combine, we have been talking about FHIR, but the same could be for DICOM, could be for OMOP, for your research data. You could combine it with your custom data, all in the same database. And this flexibility that we can provide here in the model itself, combining the different standards, you can also have this flexibility to retrieve your data. So using MQL, the MongoDB query language, to retrieve your data, or building your own FHIR API on top of it to consume the data in a canonical way. So you could have the same repository providing exchange interoperability functions to third parties while consuming internally this data using MQL. And for data analytics, your researchers used to SQL, they could also leverage the SQL interface to build their analytics without the need of duplicating the information. And if you go in this way, you can benefit from advanced features without waiting that the vendors that you have involved in your interoperability solutions are locking you to the last innovations. For instance, adding vector search. So adding vectors representing the meaning of clinical notes, for instance, that you want to allow the healthcare professionals to do natural language queries across all the data in the organization. And once we have convinced the customers to use MongoDB data model to model the data in the organization, they will be able to leverage advanced functionalities from the data development platform that is benefiting from time series, geoqueries, full text search, vector search that I already said, and this in a multi-cloud environment. In conclusion, you can address the dual challenge of modernization and interoperability step to step, starting today, modernizing your application. So you can start with one application, refactor the application, embedding the interoperable object inside it, and then you will close the gap between both journeys. And at the end, you will have a data-driven organization. So that's the presentation. Now we'll jump to a demo where we'll be viewing this in action. Okay? Okay. So let's go to the demo. The demo is built around a patient data journey that we say on the breast cancer. We start with the prevention, with the screening campaign for breast cancer. That is performing mammographies to women between 50 and 70 years old that once a year or every 2 years they need to perform a scan. We'll be showing some of the functionality of MongoDB because we have built an API, FHIR API on top of it, using HTTPS endpoints and access control that will have also Atlas search, change streams to replicate the events, the changes in the database, fast to have a good user experience, then integration with buckets of the medical images and atlas charts. We simulate an organization like that, where there are several radiology centers distributed across a territory, and they report to a national healthcare agency that could be also an insurance through FHIR. When we go to the data model, is what I have been talking in the presentation. We have this demo virtual hospital database with all those collections. Most of them represent FHIR object. For those who don't know how FHIR defines the resources, they have this list of 158 resources, and they define everything from a patient, a practitioner, an organization, but very complex objects like medications, interactions, allergies, everything. So if we select one of them, we will see that we have the structure of the object, and the object can be represented in JSON. So if we go back to the demo, we see here that, for instance, we click in diagnostic report, and we see the collection here with the resource and the metadata. In a resource, it respects the FHIR original object, and then we incremented or enriched the document with some information that informs about the tenant, if it's a multi-tenant application, but also the FHIR version, and here we have added vector data. This information, the vector, is representing the presented form that are clinical notes in the diagnostic of the doctor. Also, we have some other collections that are not FHIR. For instance, we are talking about DICOM in this case. We have here the series of DICOM images with the image metadata, with all the metadata of this image, including a URL for storing the binary object in S3 bucket. Okay, let's go back to the presentation. Once I have explained the data model, then we'll go to diagnostic, and in the diagnostic we'll focus more in LLMs, vector search functionality. Okay, so directly we go there to the user interface, and as you can see here, I'm logged as Bea Campos. Bea Campos is supposed to be a radiologist from the San Antonio clinic, and what she has here is a list of appointments from women that planned the mammography screening during the next coming months. We can filter through these facets, and we observe how everything is going fast, while here we don't have too many appointments. It's around 4,000 appointments. We could also leverage this full text search functionality that is integrated using the same API, one single interface. And we see that I entered an error. I said Paola instead of Paula, and was able to find it. So we can have all this fuzzy search and advanced full text search functionality integrated using the same API. But what Bea Campos is supposed to do is to search for these patients that are booked for today. And we see that she has still 9 appointments to go on during today. And we imagine right now that Vicenta just arrived to the hospital and we need to start the screening. So we click start, and we start with the first image with the radiology scan. what we have done here is that we generated an image and extracted the metadata from this image. And then there is a process that is happening now in parallel, that it will evaluate or calculate the suspiciousness of cancer of this patient through a BioRATS score. That is done with Microsoft Fabrics using Synapse. It will take some time, but it will appear. We'll continue for the next images here. This is the process. So for every interaction to the database, we are updating in several stages to create the metadata, then to upload the binary to bucket, and we obtain the URL and we obtain the document again. And finally, we generate the BioRATS score and we update the database again. And for every event, we use the change stream to update the user interface. Well, this is not happening right now. Don't know why, but it should appear BioRATS score. It's a demo effect, so let's continue. So now imagine that we also require a biopsy. So we click here and we generate a biopsy. Also, we obtain the metadata associated to this biopsy, and also using Microsoft Fabrics in the cloud, we are able to get the malignancy or benign of this possible tumor. Finally, the radiologist should be writing clinical notes. And we have this form here that I should be able to write, but I'm not a radiologist. But we integrated this practical button that is basically creating the report for us. It's random, it's nothing serious, it's just to generate, in the purpose of this demo, some unstructured data that we will require to generate vectors on top of it. So this is the information, and finally we save the report. If we look at what happened behind the scenes, is that we have called an asynchronous process, that this process basically has done everything like what a radiology scan would do. Scan the image, generate the metadata, interact with our server to upload, to generate the URL from, or the obtained URL from S3, etc., etc. And at the end, we save, before saving, we generate a vector from the conclusions. So the conclusions that are written by the healthcare professional are converted in a semantic model of this information, represented by this multi-dimensional vector. And lastly, all this information together, that is the information from the study, metadata from each of the images, including the URLs, and the vector, everything is stored in MongoDB. So now what we will do now is to change to another user, that is Eddie Grant. Eddie Grant is a supervisor in the schema that I have been talking before, is in the national healthcare system. And we observe that some things in the demo have changed. For instance, he doesn't have access to the name of the patient because he only needs to consolidate data and to understand how the campaign is proceeding. Here we are dealing with many more appointments, and the interface is working fast, same. So having the data model, just using those file resources doesn't affect the performance. We could increase, of course, with many new resources, building the correct indices for it, of course. And now, it appeared also this type of functionality. With the advanced search, we could ask for reports in the database. We have these already created examples like this one. Show me cases where additional tests are recommended. And I can just enter, and it will load a bunch of reports that it's finding in the database, that all of them are suggesting new tests. For instance, this one tells further diagnostic evaluation, including additional mammography. So new test is suggesting new tests, but is using different keywords from the original search from the user. The same for the second, further evaluation required, and this for the rest of them. So it's a very practical way to find information in our database, searching by meaning rather than searching per exact matching. We also have another functionality here, that is the RAG. We could ingest data from documents that we have, protocols in our hospital, or in this case, in the setup, what we have are some files that are breast cancer guides emitted in Europe in this case, and we could select all the documents we want to upload to the database, and we are processing all these documents, and all this data will be stored here in the patient guides collection, just as the chunk of the data that we obtained from the document, but also the vector that has been generated from these chunks that normally they have around 1,000 characters, while they can overlap to the front and to the back with other paragraphs. And also we save some information to understand the context, where we have generated this information from. And once we have this, and I will stop this process because I already generated these vectors before, we could ask questions. Questions like, what stage 4 breast cancer stands for? And we click enter, and we will obtain a nice, easy to read answer that we could even complicate more the question. Is it curable? Which are the most common treatments? And as we see here in the bottom, we obtain where this information has been grabbed from. So we can read here that stage 4 refers to metastatic breast cancer, and is not curable, but is treatable. It's not curable, but it is treatable. And the most common treatments are these ones. So it works pretty well. All the things that we have been showing now is that we're working on top of MQL, the MongoDB query language. If we come here and we apply some filters, we see that in load appointments, we use the match operator for the book status, that is the one I selected. Also to calculate the age, we have the birthday filter, etc., etc. But we could change this to HL7 FHIR, that we have built it on top of HTTPS endpoints and functions in MongoDB. And go back to the same application, also apply some filters, and we see now here that the function that we are calling, the endpoint that we are calling, is a canonical FHIR API for the search API. So we have this, that is the appointment endpoint with all the parameters that are passed to the endpoint. And we obtain a bundle, FHIR bundle, with the array of entries with all the resources part of this search. So we can combine from the same data model different usages inside our applications. At the same time, we can run this everywhere in every cloud, which is very important. And finally, we have these charts here that we have these atlas charts where we build BI functionality, this representation of the data on top of the document model natively, so we can easily follow up what's happening in the breast cancer campaign. But we could also integrate partners like Microsoft, using, in this case, Power BI. It should be locked in before. Anyway, we can benefit from advanced features from Microsoft Power BI, in this, even with AI tools to analyze the behavior with treatments, patients, and this is just a sample. It could be much more complex, but we have all the data that is inside the cloud from Microsoft. In this case, in Microsoft Fabrics, and the data is in one lake, and we can benefit from all the functionality that they have there. So that's thanks to the SQL connector that we built together with Microsoft, and they certified. Later, Q2, there is a common presentation with Microsoft and MongoDB, and they will focus much more in what's possible in the combination of Microsoft AI and MongoDB. Okay, and now to finalize, go back to the presentation, and we can hand over again to the slides. But what we have shown is this slide as a summary that I have shown before, that we are really simplifying how you work with this healthcare data that is very complex. And you can integrate all the interoperability all together and have flexibility on how to access all your information. So that's all. We finished. I'll be here around, so if you have any question, I'll be happy to answer it. I was thinking the last, there was a last slide. Okay, but it's okay. Okay, thank you very much. Hopefully you liked.